Yeah, hello all. Good evening. Thanks for joining. So let's wait for 1 more minute and we'll start the session. In the meantime, can you guys hear me and can see the screen? Please confirm in the chat. Anyone? Okay. Yeah. Thanks, Patrick, for confirming. So yeah, let's wait for 2 more minutes and start. Is it already time? Is it? Okay. Yeah. It's already 8:02. Let people join so we can start in the meantime. Okay. So we will continue with the demo. And yeah, so I will come to this slide at the last. And let me quickly repeat the general information that tomorrow's session is also a demo. And from the fourth session, it will be only for the paid candidates. The Zoom link will be sent. And the first two sessions recording means yesterday's and today's recording will be uploaded in the YouTube channel. And yeah, so please don't do any batch shifting or there won't be any refund either. And this is the WhatsApp group link if you don't have it already. So let me share it. Yeah. So just click on that link. It should redirect you to the WhatsApp group. So in this group, if I'm not available on certain day or something, it will be posted over there. Okay. So yeah. And yeah, the recordings, all and recordings, notes, and everything related to our course will be uploaded in the logiclabstech.com, the Graphy link. Okay. And the support team, please, like any payment related or session issue, anything like Zoom link is not working, or any such technical issues, or even related to our course, you can drop an mail or you can even contact to this phone number via um, if you contact this one and they will like only during this time you just contact them because this is the business hours and they are available from Monday to Saturday. Okay, so yeah. Zoom ID and password, you can create it yourself. Uh, Dorine, sorry if I'm mispronouncing your name, right? So you can you just create your own Zoom link and password. Okay, sorry. You are already logged in, right? So now there is no need to create an ID. But if you join the course, right? So a new link will be sent. Just like you joined now, you need to join that one. But once you enroll the course only, you can join. Okay. So yeah, this is the one. Anyhow, you're already in this one, right? So no issues. But yeah. Let me share the payment one. So once you paid for the course, you can a new Zoom link will be sent tomorrow. Okay, so once, yeah, this one. Let me send it here in the chat. Once you, it's with my phone. Okay, no problem. So you just click on this link. Once you paid with your desired payment method, then tomorrow there will be a new link will be sent to your email ID. So here the once you log into this portal right away, if you click on login, it will ask for your email ID and password. So once you sign up, give your actual email ID, then you will receive the Zoom link there, and directly you can log in, and it will right away log in. Since the Zoom is SSO, single sign-on is there. If you are not having a Zoom, it will try to install, and please do install it, and then create an account and then you're good to go. Okay, so right away you can see the Zoom in your calendar. Okay, sorry, our session in your calendars, and yeah, so every day at 8 p.m. IST you can see it, Dorian. Okay, so yeah, um, let me start. Okay, so today is the day 2 for our batch. And the first one before proceeding Linux booting procedure. And so we will be seeing the what is virtualization and what is the difference between virtualization and containerization. Because without understanding virtualization, you cannot proceed further, especially in current situation. Because without virtualization, there is no infra or any company you have. They are not only relying on one single system, or let me rephrase that. So a single application is not dedicated for a single machine. Obviously, each machine has multiple operating system, which is a new one, right? So again, it's not a new concept wise, but like in, let's say, let's go back in time for like 30 years back, it won't be the case, right? So a single system is dedicated only for one application because it will run out of system resources if it tries to run multiple applications. Okay, so I'm not talking about the basic applications like this Paint or some for File Explorer also. Your actual applications like your DB or multiple DBs in a single server, right? So it is actually impossible in those days due to your system resource constraint because those days like the memory itself is a huge thing, right? So you will easily run out of memory, and so okay, so like that, even hard disk and everything used to be a huge thing, and it will be literally only one application it can afford. Okay, so like that it used to be, and after like late 90s, there is a breakthrough in this concept, which is called as virtualization. And who pioneered that? Your VMware, which is what we are using, right? So they are the one. Actually, there were previous models and all, but VMware, like outright, they done a good job by creating a new layer of virtualization. And how it works, let's see one by one. Okay, so firstly, let's create a layer here. And this is my base OS. And here is my VM. Let me type it, okay? So don't worry. Uh, So, okay. So firstly, this is virtualization. And this is my base OS, which is nothing but my Windows 11, the one which you see, right, in my mission. So this is Windows 11. And on top of that, I'm going to install VMware Workstation. Okay, so in your production servers, it will be VMware vSphere. Okay, so what the core concept both are same, guys. Okay, so as I told, the user interface and the options on the features will be bit different, but the base concept as a virtualization, it is the same. Now, let's see what is actually virtualization, what it does, right? So as I told, let me give a example as Tally. Okay, so those days Tally, even now it is important tool. So Tally, some version 3 or something. Okay, so you're running Tally 3. So in those days, it is only one application you are allocated for your system resources. What are all the system resources, guys? Can someone put it in the chat? Let me give a hint. CPU is one. We did listed this yesterday. Let's see if someone gets it. And you can be wrong, guys. There is nothing like it's not a test or something. Just if you remember it, just type it in the chat. Let's see if you guys remember it. One is CPU, and the next one is which one? Anyone? Exactly. So the most important one is memory, disk, and network. Also, your GPU. In some cases, only GPU matters. In not most cases, a few applications only requires a GPU acceleration. So yeah, fine. So these are all the system resources. Now, Your system, obviously in those days it will be very less. Your CPU will be only one core, let's say, and your memory is just 512 MB. Okay, so even that is a huge thing though, those times. And your disk is maximum of 20 gigs you are having. The network is even a very basic. Let's give one Gbps or something. Right? So your GPU is very low in VRAM or something. Okay. So the point is you are allocating your whole system just to run this application. What if you're decommissioning this application, which means you're not going to use that application anymore, or your application is running from 9 to 5, the business hours. But in the remaining hours, your system will be idle state, which is fine. In as an end user, it is fine. But in a production environment, you are actually paying for the data center like 24 bar 7, it should be running. You are paying for the current or your electricity cost and everything, right? So it's literally waste of resource. And in that meantime, you can run some other application in that machine, right? So like that, okay, this is one server. Like that, let's say you're having a server farm or a data center, which is around thousands of servers is there. So it's a huge waste of a resource. Like in exponential way, it is in waste of resources, right? So how you can efficiently use it. So now that's a problem, right? So VMware came up with a solution called as virtualization. So what it does, your virtualization, it basically uses all these resources and it can be shared among different operating systems. So let's check take as an example, Tally 3 can only run in Windows. Okay, so just a scenario, fine. But what if I want a new software which should be or which actually requires Linux OS or Red, right? So I cannot run that here. That's a constraint, right? So all these kind of 2 to 3 problems, your VMware or virtualization is resolving. So how it does, let's see. So with a very important term called as resource sharing it is. So basically, your system resources, your base OS, my laptop resource this one. Let me give my actual CPU core. It is around 6 core and my memory is 8 gigs. My disk is around 500, right? So all this is system resource will be shared in this layer. I cannot share or run one more OS simultaneously. Actually, there is a concept called as dual boot. Okay, so don't confuse with this concept. This is a different one, but just a scenario I'm giving. So dual boot and even triple boot is there. So dual boot means it's nothing but at the same time you have a choice to make which one to boot in the boot screen. Like once you press the power button, in the grub, there is a booting process which is called as grub. We will see in a moment what it means. But in that grub screen, actually, it asks for whether you want to boot to Windows or Linux. Let's say you have both in your machine. It will ask like this, Windows 11 or RHEL 8, like that. So if you choose one, it doesn't boot both together because when it does both goes together, obviously no, the drivers and like libraries, everything will be different one here for Windows. And for RHEL or Linux, it is a totally different one. So either of one only your hardware can support. Let's say a basic example is your keyboard. So your keyboard is compatible with Windows using a different driver, and the same driver doesn't work with Linux. It's a different way, right? So it cannot communicate, or both OS can't go together. Either one, you have a choice to choose. Let's say you are having a dual boot setup, but you can't boot at the same time. But this VMware came and resolved this issue. Like I have Windows 11 in my machine, And if I open VMware now, you see I have RHEL installed here, right? So that's a huge leap in literally it solved many issues, right? So you can share your system resource and how does this VM is running, right? So you see, it is actually, it will be very fast comparatively, right? So it's not bad nowadays, but in those days, it used to be a bit, the compatibility is not that great. And the point is, it was evolved and it is in a good state now, and companies prefer VMware, and it is actually doing a resource sharing. So it shares the system resource. And okay, so what does that mean? I cannot simply assign the whole 6 cores for my VMware vSphere. Okay, I can assign, let's say, 4 cores for my base OS and 2 cores for my VM. And the best part is, if I'm not, like, let's say, I don't want this VM. So you need not, uh, how about the physical servers means? So what if I want to, I don't want this hardware. This is, let's say it is outdated. What I should do? I need to literally sell this laptop or buy a new one, all that, right? So, but if you are using a VMware workstation, anyhow, it is relying on a base machine only, but still, here, if you are not fine with this configuration, or if you are if you want an upgrade, just within a click you can upgrade it, right? So if you want to increase the CPU, let's say CPU core, just like that you can increase this CPU core to 2. You are not restricted. Okay, so CPU core you can increase, and you can, again, all are virtual. The virtual term is very, very important, guys. Never ever forget that. Okay, so it means virtually you are using this memory not from somewhere, in from your base machine only. So if I go to my task manager and my memory, you see it is in 97% it is used, which means my whole VM is eating up my memory, right? So because it is like, it is, my memory is around 20, 8 gigs only, right? So that's the reason. And I'm running my browser and everything. So my, that's what, right? So if I run this another VM, it's not like, okay, my system will crash or something. If I run multiple VMs, then only there is no more memory in my base machine itself. So the system will literally go into hung state, or it will force close the VMware. That's the whole purpose of your Windows, not VMware. Intentionally, it doesn't crash. But if there's no more memory for Windows itself to survive, obviously it will crash itself. Okay, so that's what. From your base memory, it is allocating 2 gigs. So remaining with 7.3 in my case, because some hardware reserved is there. So from 7.3, 2 gigs, if you minus, 5.3 gigs is only remaining. And from that, my Windows is running, right? So like that, it is. So I cannot simply give, let me give a CPU example. So let's say 6 cores are there, right? I cannot give the whole 6 cores for my VM. It is impossible because my base machine also should run, right? So that's the thing. So, and it doesn't demand that much also. Your Linux, in general, it doesn't demand that much resources. So it is a very lightweight operating system. And that is also one of the reasons companies prefer this, because uh, it doesn't need, let's say, an basic example is, it doesn't need many of these tools, right? So let's say you are, in my case itself, this is a modified Windows, but you're getting the point, right? So let's say Xbox will be bundled with Windows, and Windows Store is there, which is actually speaking, it is not needed, right? So if you want, you can side load some applications, but in general, that itself is keep on running in your background, and it will consume a lot of your system resource at the end of the day, right? So those are all not needed. And your Linux, mostly if you see, that's also one of the reason end users doesn't prefer Linux because this is the actual store. Okay, so which is pretty weird, right? So it doesn't actually have much. Important tools will be there, and mostly open source is what preferred. Okay, so like this audio, video, and all. It's a very, very bare minimal um, OS or your repository and all. Everything will be an open source based only. It is good. It's not, but it might not be an alternative for that actual uh, software or tool. Okay, so yeah. So the point is the virtualization is happening in this layer, and VMware Workstation or vSphere does it. Okay, so on top of that, I'm installing my VM, which is RHEL, any version 8 or 9 you can give. And it is a full-fledged OS, guys. It's not like a base variant or just like a small OS or something, a light version or something. It's a full-fledged OS, which actually you can install in your laptop also. It does work. Okay. And on top of this only, I'm installing any software, let's say. Let me give an HTTPD as a software, a web server you're installing, HTTPD. Okay. So HTTP or web server. Let me. So this is the one. So in order to install this HTTP, and I can install multiple tools also. Let's say net backup is for backup tool, and multiple things can be running, which is impossible in those days. But here, it is actually possible, and I can even run one more instance here. So this is Rail 8 and Rail 8 dot Rail 8 underscore new or something. You can run one more instance, and until I reach my threshold, I can run it. Okay, so that's your base virtualization. And one more important thing is you can send this layer as an image. Okay, so this layer to your colleague. Okay, so as an image, you can send dot ISO or dot VMX file, right? So you can send it to anyone. You just create a snapshot or even an image also you can create, and you can send it to any, let's say a new joinee joins your team. They can simply install or run this ISO. They will already have all, it will be bundled with that ISO. So it's a ease of uh, ease of installation or onboarding. Okay, so that's the virtualization. Now, why containers, right? Right. So you might have heard Docker applications are recently, it is like most of the companies already migrated, and few huge MNCs still migrating, and they will eventually migrate to any cloud service provider and as well as your containers. So why containers are important, and what it actually or why it matters now. All of a sudden, why everyone is trying to switch to containers, right? So containers, even VMware is having an issue now. So here, what is the dependency? Let's say I want to run HTTP web server. So just like that, I can run. Can I run from Windows 11? Yes. But what if it is not compatible? Let's say, let me give one another example. There is a proprietary software which runs only in Mac OS. Let's say Final Cut Pro, which runs only in Mac, right? So that Final Cut Pro, can I run in Windows? Obviously no. It needs only Mac OS. But how I can achieve that, right? So there should be a middleman, and VMware actually achieves it, but there is a full-fledged OS just to run that one single application, right? So I want, at the end goal is to run that application, but in order to do that, I'm actually trying to install a full-fledged OS as a virtual OS and um, doing all this resource sharing, then only I can install that software. But what if there is an image of that software and there is a middleman for running that software? And I can, instead of resource sharing, I can simply use my base mission's resource itself. How does that work? Let's see. Okay, so it is an very easy way of approach. Let's see this one. Okay, so firstly, you have base OS, the same base OS, Windows 11, and on top of that, you install Docker for Windows. Okay, so till this, it's almost same. But on top of your Docker, what actually happens is Docker engine is. So what does that Docker engine does is it actually acts as a middleman and it converts the images, right? So not like just like a compiler, it doesn't convert like that, like um, a from a high level code to your machine language or something, right? So it doesn't do that kind of compilation or something. But the Docker engine, it actually makes sure the compatibility part, whether your image and the software which you're trying to run in that image is compatible with your container tool, which is your Docker. In this case, there are Kubernetes or anything. But the point is that's the whole purpose of your Docker engine, right? So, and where does that image is pulled from? So that's where your hub.docker.com. There is a, and Docker is again an open source community, and you have a lot of important images. Again, this is called as Docker image. You see, every thing you see here, it's an image. And even you can create your own image and upload it to Docker. It doesn't matter. And you can even upload and send that link to your colleague, and he can also download and use it, your image again. Okay. So you see almost every important tools like MySQL and Grafana and so many monitoring tools. Literally everything will be there, including your Linux or every um, like important OS. Everything will be here. So you see Alpine Linux. It is a Alpine is like just 5 MB Linux. It is. It has the basic system requirement for a Linux machine, and like with the file system, everything will be already there. So just you need to do Docker pull Alpine. That's it. In the Docker for Windows, and that's it. You can easily run. Instead of installing a full-fledged OS, you are literally eliminating this step, which is a huge thing, right? Because this plays a vital role, and this is also you need to consider for the compatibility. Obviously, nowadays it is compatible, right? So you're not stranded with very old machines also. And in your work environment, there won't be a old one, right? Obviously, they will use the latest to hardware and all. But the point being, this OS actually is not needed eh, here, right? So just like that, you can pull even HTTP. Why can't we take our example itself? HTTP, the official HTTP web server it is there. Right? So if I just do Docker pull HTTP, there will be a that image will be downloaded. So I can just do HTTP D. This is an Docker image. And just like that, will that image be running? No, there is an underlying OS should be there. So even that concept still, it will never change, right? So just like that, as an example, can I run a paint as as an uh, like individual or standalone application? Can I run it? No. On top of my Windows only, I can run a paint application. Just like that, any application you take, there should be a OS element. That's where your Alpine is used here. The Alpine is a, as I mentioned, the bare minimal OS it is. And that's what is needed in this case because you are just running an image for HTTP and only that. And can I run multiple images of HTTP? Obviously, yes. Right. So that's where your container concept comes in. So you pull this image and can I create multiple instance of this HTTPD? Yes. So HTTPD1, HTTPD2 like that, you can create multiple instance. And as a container, when it will evolve is this one, you have the required libraries and the required drivers or tools. Okay. So if you have all these, just with image, you cannot do anything, right? So again, it bundles the OS, but in order for the system to recognize it and running it, you need to have these libraries and drivers. And once you create a container out of it, it will be working as expected. Okay, so that's how it works in your as a container, it works. Okay, so a very, very important concept because just like that, you can upload your container here once you create an account in your Docker Hub, and you can share it with anyone. Okay, so there is no restriction. And even here, if you see for my, yeah, these are all someone uploaded, right? Just 14 hours ago, someone uploaded like that. You can even get a public anyone's image, or even you can create your own. There is no restriction. But can you do that here? Obviously, yes, you can share it with using an FTP server and you can share it with your internal company or intranet, you can share it. But it's like literally you're having a huge one, right? So your ISO itself, since the OS is there, it's around at least 20 gigs it will do. Whereas here, the size is what it's a huge difference, right? So here, the image and you're creating a containers image, right? So it will be maximum of 400. You see the difference, right? 20 gigs is, and both achieves the same thing. That's the best part. Okay, so here also you're at the end you are using HTTP. Here also at the end you are using HTTP as a web server. Okay, and here also you can share it with your colleague. Here also you can. So that's the main reason companies prefer this method. Obviously, the end goal is same and it is even efficient. It even uses less resource because you need not run an OS here. If there is an OS, but it is a very lightweight, it just needs the bare minimum to run this application. That's it, right? So, like, it's a very good thing. In terms of infra, you can run multiple containers and you can even orchestrate it. That's what your Kubernetes does. The whole purpose of Kubernetes or Docker Swarm is to orchestrate multiple containers, like which one to be failed over, failed back, and many things you can do. Okay. So that's the basic concept of virtualization and how it evolved from your base machine, which is like 30 years back or even 20 years back. It used to be like this. And recently only your containers, like past 5 to 8 to 5 years or so, like 2015 or even later, then only the concept was there. Okay, so it's not like only that time it was they came up with this. As a concept in many companies, it used to be there, but as they coined that term and it became a thing once Docker came out and they give the as an open source this tool and all. But in Google, they used to use this as an insider tool, right? So it's a proprietary tool just for their internal employees. They used to use it. Many companies, even now in banking, If you see, especially in banking, you can see a lot of tools, which might be a breakthrough if it is a public one, but they use it for their own purposes. They don't want to make it public. That's the thing. But for them, it is a very good productive tools, right? So that's what. Okay. And the industry's best practices combining both virtualization and containers. It's not like, okay, virtualization will go extinct or something. It will be still there forever. Okay. So this concept is must, right? So, and VMware is not an, like, it's not like um, obsolete, right? So it will be there forever. But there is a giant leap from virtualization and containers from here to here, right? So that's what. Okay, fine. So now, any doubts in this one, guys? If not, we will move on to the booting procedure. No, fine. So now let's see what is a booting procedure. Why this is an important one? As I told in yesterday's session, as a sysadmin, a booting procedure is too important for you to understand which one or what actually happens during the process, right? So if something went wrong, you should be in a position to know, okay, this might be the issue. Again, you might not know the actual reason. Obviously, no one can predict the reason, but at least you can say, okay, this might lead to that issue, right? So at least for that, you need to know the process on the whole, right? So that's the reason companies do ask this question. It's a very not important, it's a very standard question. So any freshers or even experienced person, they are asking this: what is a Linux booting procedure or booting procedure in general? Because it's not just for Linux. In any mission, you must go through these. Okay. So before proceeding this one, let me give a basic roundup of your hardware. Okay, so let me one second. Let me open a motherboard. Again, it's not like, okay, we will see fully hardware and all, but just a basic understanding you should have, right? Because a few people might be very new to IT and also that's what. Let me use the motherboard of my PC. Let me get an image of it. Okay, so fine. So this is the motherboard which I use it in my mission. So that's the reason I took this one. You can take any ATX or mini ATX or any size motherboard. The core components will be the same. Okay, so what are all the important components? Firstly, your CPU will be placed here, and there is a north bridge and south bridge is there. Okay, so this whole thing is your north bridge, and these are all your south bridge of your motherboard, and these are all VRMs. Okay, so and this all your input outputs that mostly we will see like outside the mission, right? So but inside these are all the components, and here is where you connect your DIMM slots. These are all nothing but your RAM. So you just place your RAM here, and this is nothing but your motherboard's 24 pin connector, and your SSD will be placed here. It is a M.2 interface, M.2 SSD. Okay, and this all slots. So in this case, how many are there? One, two, three, four, five. So five PCIe slots are there. So what is PCIe? It's like a how to say, like your graphics card, your network adapter, and many things you can connect with PCI. It's a very standard one. Okay, so this connector is what I'm talking about, and this is called as SATA connector. S8 serial ATA connectors, these two, and these are all in like again I/O for your speaker, your actual your CPU case, right? So all that connectors will be here, and you can use it. But this is the important one. Your CPU will be placed here. Okay, fine. So first step, once you press the power button, what actually happens is your there will be a small ampere of current will be sent to each and every component. And let's say you accidentally didn't place your you didn't connected your memory correctly, let's say. So your system won't even turn on, and it will be stuck in the very first stage. Okay. So the small ampere of current I told, right? So it is called as post. The step is called as post power on self test. It is like a in if you understood the way cars works, right? So it will do the priming of your fuel tank and all, right? There will be priming in any motors you take. So there is a priming. Priming, it's just starts, right? So like that, here it does that. So it will send a small ampere of current to every component, and there is an amber light here. Okay, so if there is an amber light in, let's say, CPU, and it stays on, there is an issue with your CPU. It is not compatible with this motherboard, like that. Okay, so there can be multiple factors. I'm just giving a basic idea. So this is a hardware issue, or something went wrong in your hardware. Let's say your fan is not working. There is no fan here, but actually on top of here you have a heat sink and fan and all. So let's say the fan itself is not working, means your CPU literally it will turn on within 2 minutes. It will be automatically it will shut down. Okay, so the reason being the fan is not spinning. Like that, like you can have at least 100 plus issues you can come up with these components, right? So there can be a loose cable or over voltage or something, right? So the point is the first step itself, it can go wrong. So you should be in a position to analyze and resolve it. If it is going fine, then you should move on to the next step. The system will automatically move on to the next one, which is again an important step, which is called as BIOS. So what is BIOS, right? So BIOS full form is basic input output system, right? So again, what does that mean? Your all your IO devices. So what is your IO? Can someone put it in the chat? Let's see. What are all the IO devices in your machine? Anything, whatever you which comes to your memory, you just put it. Through which I am communicating to my exactly keyboard, mouse, your display, everything is a device to the machine. Exactly, joystick, anything, right? So these are all. So the one which you given Krishna, all are input device, and the output device is your display and many things, right? So like that, that's nothing but your input output. But I need to manage those, or whether it is connected or not. I need to see the status of it, right? So that's where BIOS is used. And let me quickly show you the BIOS, which is in the same motherboard. Yeah, MSI BIOS. Let me again why I'm giving the MSI as an example, because this is what I am using. That's the reason I'm giving that, and it will be the UI won't be the same for every manufacturer's guys. Okay, so let's say you are using Acer or what else? Um, HP, Dell, right? So any such companies have their own proprietary design in the BIOS scheme. Okay, so yeah, one sec. Let me get one. Okay, so this is the BIOS screen in my case. And in your case, or in most of the laptops, especially, they use this standard BIOS. Okay. So what it does have all the system informations and everything, right? So your system time will be there. Very, very important, guys. The system time is not as same as your time which you see here. This is different. That is different because this is fetched from the internet. There is a thing called as time server. Actually, we will do all these concepts. Okay, so you see there is a time server. Based on this only, you see the time here, but this is not as same as your system time. Okay, again, it will be same like the time or the time zone, everything will be the same. But if you reset your system time, it will go to like GMT time. Okay, so GMT time zone, and you need to change it to IST and all. So that's a whole another task. But the point is, both are not same. Okay, so that's what you see: system time, date, and your system memory, how much it is used, all your systems information, right? So here it is even clear that your motherboard's what it is, and your CPU memory, what is your CPU's voltage is there. And again, there is a concept called as overclocking. I won't get too deep into that, but the concept is if you want to use the full potential of your CPU or memory, you can actually overclock it. Means you just increase the frequency here and it will be used to its full potential. So in my case, you see the CPU base speed, it is actually measured in hertz. Okay, so it is 3.3 gigahertz, and I can increase this, and this is supported. Okay, so my AMD machine is supported, and I can increase till 4 gigs, not 4, sorry, 4 gigahertz. I can, right? So like that, I can increase the speed and I can decrease it, and based on that, obviously, voltage will be varying. And you have different versions, and the most important information here is nothing but your boot priority order. So the next step, which one I need to boot, that's the important thing, right? So till this, your system does for sure. Any system, let's say you take a Raspberry Pi, which is a very smallest computer, and if you take a very huge machine also, still you have these two. One is your power on or off button, and the next one is your BIOS screen. After that, which one I should boot? That you should decide, or you should give an input to the machine, right? So that's what your boot priority order does. So which is a booting devices, right? So you can't boot it to some random device, right? So again, it's just a machine, right? It will try to boot to that one, but you should be in a position to know, okay, this is an empty disk, let's say this is an empty hard disk. You cannot give this as an bootable device at first in the order. It should be in some other uh, like it should not be the first one to be booted, right? So the boot disk or your OS disk should be first always, and then only you can boot your OS. Or if you have an ISO or some software or anything you want to boot, you can change this order. It will be booted as per this order. Okay, so that's your boot priority order, and that's the main purpose BIOS is there. One of the main reasons. And also you can control your CPU fan, everything you can do here, right? So I'm just giving just uh, 5 to 10% of what it does. So many things are here. Okay, fine. So just boot in order, and it is, let's say, hard disk and SSD. And what is the full form of SSD, guys? If you guys know, let me let's see. What is HDD and SSD? What it actually means or what it does? It is storage. Okay, so the different ways you are having storage, it is hard disk drive. This is called as solid state drive. Okay, so again, why there is a two different concepts? Because these two are not the same, first thing, and two work in a very like they approach the data in a very different way. There is one more called a tape drive, which is like nothing but you used to have tape recorders in your home, right? Those days. So exactly like that. Even now, tape drives are there. Okay, so to store data in huge quantity, you can store data in all the three methods. But which is the fastest and the preferred one nowadays? Even in my machine, I have SSD, solid state drive. Okay, so you're it because first it is very small in size and it is the fastest compared to your hard disk and tape drives. Okay, so yeah, let me just quickly give an image of hard disk and SSD so that you just remember this forever, right? So that's what. Um, okay, this is. I just need to give a basic idea. Okay, this should be fine. The first image. Okay, this is yeah. So here you actually have a disk, not one disk, multiple platelets will be there, and it is just like different plates. Like again, depends on how much size you have, right? So if you are having a hard disk of 10 TB, there will be more plates, right? So and this IO head, this is the actuator you see here, right? So this one, it will be too fast actually. It will keep on moving in this direction and it will see for the indentations in your disk. Actually, this is almost like a mirror it will be, but you will see some small indentations there. That's nothing but your data. Okay. And that's the whole purpose of your hard disk. There is a physical disk here, whereas here there is it since why it is called as SSD. There is no moving parts here. It's just different chips, right? So there is a controller for sure. There is a cache chip, and there are different storage chips. And the here, will there be a wear and tear? Obviously, yes. If you somehow dropped it, it will be damaged. This IO head will hit this plate, and your data might even be corrupted. Okay, it can even lead to a data loss. But whereas SSD, since there is no moving part, it is kind of prone to any accidents or something. Okay, so that's also there. And this is one interface, right? So this is again SATA only. So this pin, and you have like this chip is also there. So this is your M.2, or there are multiple interfaces. Okay, so like this. It's like nothing but your a small chip it will be, guys. Okay, so yeah, fine. So that's what hard disk or SSD and even CD drive. Anything if you want, you can boot to it. Okay. So let's say I selected hard disk, the first one. The next step is it will try to boot to that disk. And now is the important step which many people will ignore, which is called as MBR. Okay, so what does that MBR means? We'll see that. So your disk is a collection of blocks. Okay, so for us it is just an empty space, but for the mission it is like multiple blocks, and each blocks has its own weightage. Let's say 10 MB will make one block equal to one block. Like that, you're having cluster of blocks, which means um, again based on your size. Let's say you have, in my case, I have 500 gigs of 512 it is okay. So, but only 476 is usable, and in that, if you divide this by 10, so those many blocks are there. Again, I'm just giving a rough estimate, but that's how the system will see your hard disk. Right? So it doesn't see it as a and just a disk. It is a block devices, and yeah, okay. So that's the first thing, and the next one is your partition style. So just like that, can I use this disk? No. And will everyone or ever will we call our mission as okay? So let me go to disk zero. In like that, we will mention no, right? In Windows or even in Linux, we don't do that. Okay, so there is a partition involved, and even again, it's not like okay, I must have multiple partitions, then only I can use it. No, I can have a single partition also using the whole disk. Even that is possible, right? But still, there should be a partition. Why there is a need for a partition? There is a thing or the most important one in your disk management is file system. So mm, again, as I mentioned, it is a just a bunch of blocks or cluster of blocks. But how to make use of it? It will be just like that forever. But in order to use it for our need, we need to change its um, how to say we need to do a makeover for that. So that makeover is performed by this file system, and there are different file systems, right? So what it does basically, it will give an identity to that data or data blocks, right? So there is a thing called as metadata, and which has what is the block size, what is a sector size. Sectors are again there are few blocks can make a single sector like that. You have multiple sectors within, and you can even have tracks. Okay, your hard disk tracks will be there like this. Let me do a concentric circles like this. Your tracks will be okay. So multiple tracks will create one side like this, okay, and you have different sectors like this. Again, all are virtual, guys. Okay, so this first one is a separate or single sector. Like that, you have multiple sectors in your hard disk. Again, depends on your size. Let's say you're having 20 TB of hard disk, the sectors will be the count of sectors will be huge, right? So that's why. And yeah, so pretty much that's how your system will be approached. And in order to have these many, you know, like definition, you need that file system. Okay, so file system, which is NTFS you might see in your Windows and XFS in your Linux and FAT32. So you might have seen that in your, let's say you formatted your pen drive anytime, you might have seen this FAT32 or exFAT is there. It's a huge list. Okay, so we will see this extensively in our disk management. But the point is, this is the partition or file system. And there is one more thing called as partition style, and this is where you have two options, which is MBR and GPT. Again, as an end user, you will never ever, you might have heard this term called as MBR, right? But even GPT. But in our case, which one is used in Windows by default? It is GPT. You see, partition style GPT. What is actually mean? What is this GUID partition table? So it has, again, not only for this primary partition, it does few more things. Okay. Again, we will see extensively this one in later sessions, but as of now, this does have 128 primary partitions, and GPT is the preferred one in Windows by default. You will never see this option or this settings while you install your OS, or even now in your machine. If you check, it will be GPT. Okay. And can I convert this to MBR? Yes, you can, but it is not recommended by even Microsoft. Okay. And what is MBR? MBR is a legacy support, means any machine except Windows nowadays will use MBR, including your Linux. So it is nothing but master boot record. So how the data is being consumed or how it is approached. So that's what your partition style will be, right? So let's say I want, for basic example, let's say I have a data, I have an image, a new image. So I want to store it in which sector, which track, and how, is there any empty block there? So everything will be literally taken forward by this partition style. And the disclaimer is GPT is the fastest compared to MBR, but the compatibility factor, MBR is being used for quite some time. So yeah, so here you have only four primary partitions. So what is this primary partition, and why there is a need for, as I mentioned, without partition, you cannot use anything in your machine. Fine. But why there is only four? So that's how it is. Okay. So if you have, so in your MBR, you have one, two, three, four, five in this case, right? Again, I'm considering the unallocated. So in your work environment, mostly it won't be unallocated and all. But let's say there are five partitions. Actually, in your MBR, you cannot have five. You can have only four partitions. The fourth partition will become as a container, and you can use that as a uh, inside that you can create a logical partition, and with that you can do whatever you want. And this, whatever I explained for the past minute, it doesn't make sense as of now, but we will see extensively that in later sessions. And it's a very interesting one, how the data has been consumed and how it is it works, right? So a very good one it will be, so don't worry. Okay, so the next one in MBR, let's say you selected the first boot sector. So let's say this is your boot sector. What is inside this one? It will be grub. Okay, so this grub is what will be residing in this boot sector. Again, one thing can happen here, guys. So let's say your hard disk is corrupted, or it is having some like controller failure, right? So many hardware issues can be there. So if it is there, the system will be stuck here itself. It can't proceed further because there is an issue here, right? So that's what your system will boot till here. And if the issue persists, it will again reboot. So it will be in a boot loop. So it will reach till here, again it will reboot like that. Okay, so now what is grub? So grub is nothing but grand unified bootloader. And you might have heard this bootloader term if you used Android as a power user. If you are a power user of Android, for sure you might have heard this term called as bootloader because not only in Android, any device you take, bootloader is what defines as a so in the system design itself, what should be acted on, right? So let's say uh, I, for example, the basic task. Let's say you want to copy a file. So what is the steps you take? You just Control C from one point, and you're copying it to some new directory or new folder, right? So some path, and you just go there, right click, paste, Control V do, it will paste. But there is an instruction set for this. We can we literally do this, right? So Control C, Control V, that's it. But in terms of the system, there is a thing called as instruction set, right? So that's how for each and everything there will be an if else. So if he copies it, and if he what if I copy some other data in between, that will be the preferred one. So the previous one which I copied will be replaced, right? So it won't be copied now. So the new one only will be copied like that. There it's a very huge if else will be there, right? So the point is like that. What if your once my system is trying to boot, which one to be preferred, or what are all the modules needed, what are all the drivers need to be, right? So like that, there is a huge list of action items or instruction sets, and that's the whole purpose of your boot loader. Okay, and not only here, guys, any device you take, there will be a bootloader. And why I mention Android specifically is you need to unlock the bootloader in order for you to install some other OS or other version of Android. If you want to do, you need to unlock your bootloader. Then only you can. That's the reason you might have heard that term before, especially in Android. But yeah, so now coming to this concept, what does Grub do is here, basically you are stuck with, as I mentioned, dual boot is there, right? Before. Like that, what if you have multiple OS in your machine? So this is the place where you will select it. Okay, so Windows 11 and again Windows also can be there. So let's say Windows 10 and one more, let's say Linux or RHEL 9. So it's not like, okay, it should be a different OS, then only you can install. If all these OSs are in the same hard disk, it will be detected in the grub and you can see it, right? So you need to choose between, okay, I need to boot to Windows 11. For the time being, Windows 10, again, it is session based, right? So if you are for the timing, only one is allowed, which one you need to boot. So the screen is what grub means. Let me show that grub screen here. Grab screen, Windows, and Linux without root. So you might have seen this screen, right? So Ubuntu is there. Windows Boot Manager is also there. Like that. In Windows, you might have seen like this. Windows 10, Ubuntu. And you might have seen this a basic one. Linux Mint, Cinnamon, and Windows 8 is here, right? So the place where you choose your different OS, that's nothing but your bootloader. Even now, if you restart your machine, you might have, you can even see that. But in Windows, if you have only one instance, it doesn't show this one. Okay. So what is an example is, let me restart this VM itself and quickly show it to you. And sorry guys, actually today also I exceeded the time. So just give me 2 minutes. Yeah, this is the grub script. Okay, so here I have two options. One is this actual OS, this one 8.2, and the next one is a rescue version of it. What if this machine goes broke, right? So then you need to fix it, right? So that's what this rescue disk or rescue option is. So, but this is your grub screen. Okay. So press enter. So now is what your kernel will be loaded. So till now, you're just choosing which one to be preferred. So now actually your OS is booting and it loads everything, right? So if you see here, it loads, okay, it's already loaded, but it loads almost everything, like your disk management, user management, every tools related, everything will be loaded. And that's your kernel, which we will see in tomorrow's session. Okay. So still kernel, init process, run level, all these three more steps are pending. And we will see that in tomorrow's session. Okay. So yeah, again, I'm not giving a full-fledged explanation, guys, because just with BIOS, we can go on for another 3 more hours. Okay, so it's like even more than that. So just with this overclocking, it's a huge concept wise, right? So that's again, there is no need for you to have that much knowledge in the day one or day two itself. Or let's say you're starting your career itself. Uh, that much knowledge is actually you don't use it anymore, right? So only with experience, you might have a chance to use that. Again, for your personal use, you can use it. But the point is, over the period, you will understand, okay, how the system is communicating to different components, hardware level, including software. And okay, so that's what this is kind of a niche environment. So if you want to if you are really interested, you can go beyond the expectation and you can even do advanced, uh, not just courses, advanced knowledge you can have almost every important concepts. Okay, fine. So let me do the task. So again, so with this, you are tomorrow also demo one, but only for the paid candidates, the demo link will be sent, guys. Okay, so yeah, tomorrow the link will be shared, but the recordings won't be there. Okay, so you can join with the same Zoom link even tomorrow. But if you are fine with my way of training, so please do join with this link. And yeah, so is there any doubts till now? Anyone? Again, I might have started somewhere and I might have ended, but the point is that's how it is. Okay, so we will go a bit slow in at least for a few sessions, and then we will uh, ramp up and understand much more. By that time, you will get used to all these concepts. Okay, so yeah. Is there anyone, any existing like Linux users here? Like you're already a Linux admin. Anyone is there? Adil told he was, but I don't see Adil today. Anyone like Krishna, Narayana, Prabhakar? You're an existing Linux admin? No? Yes. Just open to user. Okay. Okay, Narayana. You're an existing Linux guy. Okay, fine. No problem. So yeah, so in your case, it will be just a brush up of all the concepts. And okay, so uh, just giving an idea, like the course will be from the basics and don't think that, okay, this is too basic and all. But yeah, so you'll get used to all these if you are fine with this path, your career path, right? So yeah. Okay, then so it's already time, guys. So let's see tomorrow at the same time. Okay. It's also free demo. It is a free one, Satvik. Okay. So you just join tomorrow session. It is same time. It will be free. What about post content? You can see the course content here, right? So just go to the same link, and if you scroll to the last, you see the course content here. You just click this, you can download it, and you can see here. Okay, fine. So yeah, guys, then can you share the link? Sure, let me share it. Um, Sorry, Satvik, the time can't be changed, right? So uh, for sure, it is just from 8 p.m. to 9 p.m. But if you're not fine with the time, you can enroll to this course, which is a pre-recorded one, which is nothing but my previous batch. Okay, so you can even enroll to this one. This is only for Satvik. I'm just sending a link to only you. You can enroll here. Okay, so fine, guys, then. So it's already time. Let's see in tomorrow session, we'll continue the same. Okay, so yeah, thanks all then. Cheers. Bye bye. Let's see tomorrow, guys, then. Bye bye.